The North and South Poles are located at the extreme ends of our planet, but they are worlds apart in their geography and formation. The North Pole, often visualized as a snowy expanse, is not a landmass at all. It lies in the middle of the Arctic Ocean, which is covered by a constantly shifting layer of sea ice. This ice cap, while thick in places, is relatively thin compared to the ice covering Antarctica. In contrast, the South Pole sits on a continent, the vast and icy landmass of Antarctica. Antarctica is a high, mountainous continent, buried beneath an immense ice sheet that averages over a mile thick. This ice sheet holds about 90% of the world's fresh water, making it a crucial component of Earth's water cycle. The formation of these polar regions is also distinct. The Arctic Ocean, relatively young in geological terms, formed as the continents shifted and the Arctic basin opened up. The sea ice, a defining feature of the Arctic, is formed by the freezing of seawater. Antarctica, on the other hand, is an ancient landmass. It was once part of a supercontinent called Gondwana and drifted to its current polar position over millions of years. These geographical differences, though thousands of miles apart, are pivotal in shaping the unique climates and ecosystems found at each pole. Understanding these differences is crucial to appreciating the distinct challenges and wonders these regions hold. The North and South Poles are both known for their frigid temperatures, but their climates differ significantly. The Arctic, being an ocean surrounded by landmasses, experiences slightly milder temperatures than the Antarctic. The presence of the Arctic Ocean helps moderate temperatures, with average winter temperatures hovering around -30 degrees Celsius. The Arctic also sees more variation throughout the year, with distinct seasons and periods of continuous daylight in summer and darkness in winter. The Antarctic, being a landmass surrounded by ocean, experiences much harsher conditions. It is the coldest, windiest, and driest continent on Earth. Temperatures in the interior can plummet to -80 degrees Celsius during the long winter months. The Antarctic also experiences katabatic winds, which rush down the slopes of the ice sheet, creating fierce blizzards that can last for days. The tilt of the Earth's axis plays a crucial role in the extreme seasons experienced at both poles. During the winter solstice, the poles are tilted furthest away from the sun, resulting in months of darkness. Conversely, during the summer solstice, the poles are tilted towards the sun, leading to months of continuous daylight. These dramatic shifts in daylight hours influence the life cycles of plants and animals in these regions. Despite the harsh conditions, the Arctic and Antarctic are teeming with life, each hosting unique and fascinating ecosystems. The Arctic, with its ice floes and frigid waters, is home to iconic species like polar bears, walruses, and seals. These animals have adapted to survive in a world of ice and snow, relying on their blubber for insulation and their hunting skills to find prey. The Arctic Ocean, rich in nutrients, supports a diverse ecosystem of fish, crustaceans, and plankton. These organisms form the base of the food web, sustaining larger predators like whales and seabirds. On land, the tundra regions of the Arctic come alive in the short summer months, bursting with wildflowers, lichens, and mosses. This vibrant landscape attracts migratory birds, caribou, and other animals seeking to take advantage of the brief abundance of food. The Antarctic, with its vast ice sheet and surrounding Southern Ocean, supports a different but equally fascinating array of life. Penguins are perhaps the most iconic Antarctic animals, with several species, including emperor penguins and Adelie penguins, thriving in this harsh environment. Seals, whales, and seabirds are also abundant in the Southern Ocean, feeding on the rich krill populations that form the base of the Antarctic food web. One of the most remarkable features of the Antarctic ecosystem is its isolation. The continent has been separated from other landmasses for millions of years, leading to the evolution of unique species found nowhere else on Earth. This isolation makes the Antarctic ecosystem particularly vulnerable to human activities and climate change. The allure of the unknown has drawn explorers and scientists to the polar regions for centuries. Early expeditions, often fraught with danger and hardship, sought to chart these icy frontiers and unravel their mysteries. Roald Amundson's successful expedition to the South Pole in 1911 and Robert Peary's claimed expedition to the North Pole in 1909 marked milestones in polar exploration. Today, scientific research is the primary driver of human presence in the polar regions. Scientists from around the world work in these extreme environments to study climate change, ice sheet dynamics, marine ecosystems, and the unique adaptations of polar life. Research stations, established by various countries, serve as hubs for scientific inquiry and international collaboration. The polar regions, particularly the Arctic, are also home to indigenous peoples who have lived in these challenging environments for millennia. The Inuit people of the Arctic, for example, have developed a deep understanding of their environment and rely on its resources for their livelihoods. Their traditional knowledge and practices provide valuable insights for scientists and policymakers seeking to address the challenges facing these regions. The North and South Poles are not just geographical points, they are also crucial to understanding Earth's magnetic field. This field, generated deep within our planet's core, acts like a giant bar magnet, with lines of magnetic force flowing from the South Magnetic Pole to the North Magnetic Pole. This magnetic field acts as a shield, protecting us from harmful solar radiation. It's important to distinguish between the magnetic North Pole and the geographic North Pole. The geographic North Pole is the fixed point where all lines of longitude converge. The magnetic North Pole, however, is not fixed. It wanders over time due to the dynamic nature of Earth's core. This wandering can be significant, with the magnetic North Pole currently drifting towards Siberia at a rate of about 55 kilometers per year. This distinction is crucial for navigation. Compasses, relying on Earth's magnetic field, point towards magnetic north, not geographic north. Navigators, especially in polar regions, must account for this difference to ensure accurate navigation. The magnetic poles also play a crucial role in the spectacular natural phenomenon of the aurora borealis, or northern lights, and aurora australis, or southern lights. These displays of light and color in the sky occur when charged particles from the sun, carried by the solar wind, are guided by Earth's magnetic field towards the poles. As these particles interact with gases in the atmosphere, they create the mesmerizing light shows that dance across the polar skies. Section 6. A warming world: climate change at the poles. The polar regions are on the front lines of climate change, experiencing its effects more rapidly and dramatically than other parts of the world. The Arctic, in particular, is warming at twice the rate of the global average, leading to a cascade of consequences for its fragile ecosystem. The shrinking of the Arctic sea ice, a defining feature of the region, is one of the most visible and concerning impacts. This decline in sea ice has dire consequences for polar bears, walruses, and other ice-dependent species that rely on it for hunting, breeding, and resting. The loss of ice also disrupts traditional hunting practices of indigenous communities who have relied on the ice for generations. Furthermore, the melting of glaciers and ice sheets in the Arctic and Antarctic contributes to rising sea levels, posing a threat to coastal communities worldwide. The warming temperatures in the polar regions also disrupt ocean currents, alter weather patterns, and threaten the survival of cold-adapted species. As permafrost, ground that remains frozen year-round, thaws, it releases methane, a potent greenhouse gas, into the atmosphere, further accelerating climate change. These interconnected impacts highlight the fragility of the polar regions and the urgency of addressing climate change. Section 7. Sentinels of Change: the poles and global climate. The polar regions, often considered remote and isolated, play a crucial role in regulating Earth's climate system. The vast ice sheets of Antarctica and Greenland act like giant mirrors, reflecting sunlight back into space and helping to cool the planet. This reflectivity, known as albedo, is crucial for maintaining Earth's energy balance. The polar oceans also play a vital role in the global ocean conveyor belt, a system of currents that circulates heat around the planet. The cold, dense water that sinks in the polar regions helps to drive this circulation, influencing weather patterns and ocean productivity worldwide. Changes in the polar regions, such as the melting of ice sheets and the warming of ocean waters, can disrupt these delicate systems, with far-reaching consequences for global climate patterns. Understanding these connections is crucial for predicting and mitigating the impacts of climate change on a global scale. Section 8. Guardians of the Poles, International Cooperation and Conservation. Recognizing the global significance of the polar regions, the international community has taken steps to protect and conserve these vital areas. The Antarctic Treaty System, signed in 1959, designates Antarctica as a continent dedicated to peace and scientific research. The treaty prohibits military activities, encourages international cooperation, and promotes the responsible management of the continent's resources. In the Arctic, where territorial claims are more complex, international cooperation focuses on addressing shared challenges such as climate change, pollution, and the sustainable use of resources. The Arctic Council, an intergovernmental forum comprising Arctic states and indigenous groups, promotes collaboration on environmental protection, scientific research, and sustainable development in the region. Conservation efforts in the polar regions focus on mitigating the impacts of climate change, reducing pollution, protecting biodiversity, and promoting sustainable practices. International agreements, scientific research, and collaborative partnerships are essential for ensuring the long-term health and resilience of these critical ecosystems. Section 9. The future of the poles, our collective responsibility. The fate of the polar regions is inextricably linked to the future of our planet. As the world continues to grapple with climate change, the Arctic and Antarctic serve as powerful reminders of the interconnectedness of Earth's systems and the urgent need for collective action. Reducing greenhouse gas emissions, transitioning to renewable energy sources, and investing in sustainable practices are crucial steps towards mitigating the impacts of climate change on these vulnerable regions. Educating future generations about the importance of the polar regions, inspiring environmental stewardship, and fostering a sense of global responsibility are paramount to ensuring the long-term health of these icy frontiers. The future of the poles, and indeed the planet, depends on our collective commitment to addressing climate change, protecting biodiversity, and preserving these unique and vital ecosystems for generations to come.